Hello everyone, thank you for signing in and watching my stream. I'm Mr. Matt and that's Dr. Tot, and welcome to Algebra I. Today's live session we're going to be focusing on writing and reading mathematical expressions. So let me share my screen with you. Okay. So first of all, some vocab that we need to know. The sum of a number of values, and it could be more than two, but the sum of any number of values is going to be the answer to an addition problem. I should say and an addition problem. We also have, let me move this up here, get more space. The difference. This is going to imply subtraction. It's the answer to a subtraction problem. We also have the product. The product implies multiplication, because it's the answer to a multiplication problem. And lastly, we have quotient. And that implies division. A quotient is the answer to a division problem. Okay, so just some key vocabulary that we need to be able to recognize. And let me drag that all up so it's all spaced similarly. If you have any questions, please let me know in the chat function. Otherwise, let's take a look at some questions. Get my controls out of the way there. So I'm going to give you 1 minute. Actually, I'm going to give you 2 minutes. I'd like you to write a mathematical expression that represents the verbal expression written here. So 2 minutes, then I'll give you some hints. Okay, so the first problem, they use the word sum. So we know that indicates addition. So if we're talking about the sum of 5 and x, no matter that x and 5 can't be added together as they're written, right? Because x is not a number, so we can't combine it with the number 5. But we can imply the operation that the sentence is connoting. So the sum, the addition of 5 and x would be 5 plus x. X just stands for some number. We don't know what that number is, but right now we don't know what it is right now, but that's okay. We can figure it out later, or we might come across it later. We might be given it later. All of those situations could occur, and that doesn't change the relationship between 5 and x and 5 and whatever number that value could be in the future, that variable could be in the future. So this is absolutely fine, 5 plus x, the sum of 5 and x. The second question, the difference of 9 and some number. So they're just a little bit less specific than the first version, the first sentence that we dealt with. When they say some number, they're really just leaving it open to interpretation what variable you want to choose for the unknown value. In algebra, whenever we have an unknown value, we just use a variable to represent that number. So this question is rather subjective, meaning that there's a wide range of acceptable answers. However, it must be in the form of 9 minus some variable. So you could have said x, 9 minus x. You could have said 9 minus y. You could have said 9 minus m, 9 minus h. It just had to be some unknown variable, some variable that's representing a value that we will hopefully know in the future, but for now it's unknown. If you have any questions, please let me know in the chat function. Otherwise, I would like you to turn these mathematical expressions into verbal expressions, into worded names. So I'll give you 2 minutes, and then I'll give you I'll give you a hint. Okay, so let me give you some hints here. For the first one, look at the relationship between the values. 3 is doing what to x? It's multiplying. If they're just next to each other, if you have a number and a letter next to each other, that's implicitly multiplication. So you're going to have 3 times the variable x. The whole thing is then going to be plus 2. So first deal with the expression 3x, then deal with the operator of addition, and then the final value of 2. For the second one, we have that exponent there. When we raise something to the power of 2, colloquially or everyday language, spoken in everyday language is what I'm trying to say, we would just say squared. Okay, so that's one option. You could say to the power of 2, or you could say squared. But you're going to have to look at the relationship between 4 and x, then recognize that x is squared. Then you have addition, which we say plus this value of 5x. Okay, so I'll give you one more minute, and then I'll give you the answer. Okay, so for the first question, we would have 3 times x plus 2. For the second equation, we have 4 times x squared plus 5 times x. If you have any questions, please let me know. I'd like you to turn these written expressions into algebraic expressions. I'll give you 2 minutes. So remember, product is the answer to a multiplication problem. So you want to multiply here. We usually use the verb times when we write that out. You could also say multiplied by, but usually you'd say something times the other. Quotient is the answer to a division problem, so you're going to want to divide these two. Now, you need to know that multiplication and addition are commutative, meaning that order doesn't matter. Subtraction and division are not commutative. So there's the commutative property of addition and multiplication. There is no commutative property for subtraction and division. The significance of that is that order matters with division and subtraction. That means that when you're adding or multiplying, you can flip the numbers around and it makes no difference to the actual answer, right? 3 plus 2 is 5. 2 plus 3 is also 5. And actually, while I'm saying this, I'm sorry, I know that my screen is super small, so let me just make this up. So addition is commutative and multiplication is commutative, meaning that the order can be reversed and the problem is unchanged. So 3 plus 2 is 5 in the same way as 2 plus 3 is 5. Same thing with multiplication. 2 times 3 is 6. 3 times 2 is also 6. That doesn't work with subtraction or division, right? 3 minus 2 is positive 1, but 2 minus 3 is negative 1. 2 divided by 3 is 2/3. 3 divided by 2 is 3/2. Those last four values, when we either subtracted or divided to obtain them, order mattered. They were all different from each other. Whereas in the first two examples, they matched up. When we switched the order, it didn't change the answer to the actual problem. So be careful of that here for the second problem. We have the quotient of 8 in Q. Make sure 8 is your numerator. Okay, I'll give you 30 more seconds. Okay, so for this first guy here, the product of 3 and r is 3 times r, which we could write out as 3 times r, or this is also a symbol for 3 times r, or you could have written it with parentheses. All of these things are exactly the same as just 3r. So 3r is the simplified form, and it just means 3 times r. And remember, r means any number. We just don't know what the number is, so we are using some letter to represent it. So don't let that confuse you at all. It's just something that you will know at some point, or hopefully will find out at some point. And once you do know it, then you'll be able to substitute in and find your actual answer. But until then, we just have it as a place marker, so it holds with all the algebraic relationships that are present, and it's still valid. We just don't know what the actual number is. And for the second one, we have the quotient of 8 in Q. So you could have written this as 8 divided by Q. You could write this vertically as 8 over Q. All of those are the same thing. I want to also bring your attention to the fact that this is also the same thing as 8 times 1 over Q. And we'll get more into this later. But this is all the same thing because we can write this as a fraction as just over 1. And so that is all, those are all representative of the same value. Okay? If you have any questions, please let me know. Otherwise, I'd like you to take a look at these two problems, and please convert these algebraic expressions into words. I'll give you 3 minutes. Okay, so for the first expression here, we have a numerator of 12 times a times b. So we could write this out as 12 times a times b. And now if you have a whole quantity, you have a whole expression in the numerator, you can indicate that it's the entire expression, all of the values, the 12, the a, and the b, that are divided by 5 by saying 12 times a times b, quantity divided by 5. Okay, so the quantity means the entire thing. So you're talking about the whole 12 times a times b. This could also, you don't have to necessarily say, because these things are attached by multiplication, it's the standard mathematical way of naming these values that you don't have to say times. You could also just say 12ab, quantity divided by 5. Okay, those are equivalent statements. For the second problem, so we have a squared minus b squared quantity divided by 3ab. So notice there I skipped over the times part, and I just went straight to a squared minus b squared quantity divided by 3ab. So that's usually the preferred, it's the shorter way, more concise way of expressing that. So we have, if there's any questions on that, please let me know. Otherwise, let's look at the next problem. So I'd like you to translate this equation into, or this verbal expression into an equation, and then solve for x. I'm going to give you 3 minutes. Okay, so first let me give you some hints, then I'll give you another minute to solve. 3 times x minus 5 is equal to 20. When you're converting equations from written statements to algebraic statements or mathematical statements in general, locate the equating word or phrase. So the equating word or phrase right here is equal to. A lot of times it's just the verb is, like 3x is 5x minus 2. But sometimes there'll be phrases like is equal to, is the same as, is equivalent to. Everything that comes, and you can draw a line here, because everything that comes before this word or phrase will be on one side of the equation. Everything that comes after this word or phrase will be on the other side of this equation. Okay, so that represents the equal sign. And actually, let me get this. Let me make my camera a little bit smaller here. There we go. So we have 3 times x minus 5. So we're going to have 3 times x minus 5 is equal to 20. So notice that everything that came before the phrase is equal to came on one side. Everything that was after that phrase was on the other side. So I'll give you one more minute. Please solve for x. Okay, so looking here on the left-hand side, we have 3x minus 5. Our x's are only on one side, which is good. If they were on both sides of the equation, or if there was more than one x, then we'd want to combine like terms first. But here we only have one x, so, and it's on the left-hand side. So what is the farthest thing away from x on the left-hand side? It's this negative 5, right? This negative 5 is subtracting from the 3x. So I'm going to do the opposite and add 5 to both sides. When I add 5, then I'm going to get 3x is equal to 25. And then all I need to do is get rid of that 3. Ask yourself, what is the 3 doing to x? It's multiplying into x. So we need to divide in order to get rid of it. So if I divide by 3 on both sides, the 3 on the left-hand side cancels out, and I'm left with x is equal to 25/3. Now that's kind of a complicated number, but I left it as a fraction because it doesn't reduce, right? 25 is not divisible by 3. 24 is divisible by 3, but 25 is not divisible by 3. This, if I wanted to write it as a remainder, so 25 divided by 3 is going to be 8 with a remainder of 1. Or I could also write that as 8 and 1/3. Or the more exact preferred way is to leave it as an improper fraction, which is 25/3. On the SAT and the PSAT, you want to get used to answering your questions in improper fractions. In the grid-in portions, you're not allowed to answer in mixed numbers like 8 and 1/3. The reason being that the Scantron machines can't tell between a small and a large number. So they would read this mixed number right here of 8 and 1/3. Standard Scantrons would read as 81/3, which is not the same thing as 8 and 1/3. So you need to be comfortable with expressing numbers as improper fractions. So the answer here was 25/3. If there are any questions, please let me know. Otherwise, I'm going to give you 3 minutes. Please take a look at these two problems. Okay, so let's look at these guys. We have 3 times 10 plus 5a. So we have 3 times 10. I'm going to use parentheses to indicate the multiplication here. 3 times 10 quantity plus 5a. 3 times 10 is 30, so this will simplify into 30 plus 5a. If you have any questions, please let me know. The second one, we have 2 times 6 minus 4x. So we have 2 times 6 minus 4x. So they don't say quantity here, so we can assume that the 2 and the 6 are next to each other. And so we have 2 times 6, that's going to be 12 minus 4x. Notice we could pull a 4 out here if we wanted to really simplify. So if I pull a 4 outside of the parentheses and I divide each original value by the number I'm pulling out. So both numbers, 12 and 4, share a common factor of 4. In other words, they're both divisible by 4. So I'm putting a 4 on the outside of a set of parentheses, and I'm dividing each term by that number 4 itself. 12 divided by 4 is 3. Negative 4x divided by 4 is going to be negative x. So either of these expressions would be appropriate solutions. If you have any questions, please let me know. Otherwise, I'd like you to convert the following mathematical expressions into verbal expressions. I'll give you 2 minutes. These will be the last 2 problems that we'll go through today. I'm going to give you 3 minutes, and then we'll go through a review. Okay, so let's look at this first problem. So we have a power of 4. So after the third power, we technically have names for these, but it's less common to use them. When the exponent is 2, we call it squared. When the exponent is 3, we call it cubed. 4 actually does have a name. It's the quartic power, but we usually would just say raised to a power of 4. So we could say a, actually let me use a capital letter there, a to the 4th power plus 3 times a to the 2nd power. This is the same exact thing as a to the 4th power. Again, it's not as common to use the quartic power, but you could. A to the 4th power plus 3a squared. That's exactly the same statement, just a little bit more concise. So those are two different versions you need to be aware of. For the second problem, I'll do that in red ink. So we have 5h plus 3. And we have a whole quantity, we have a whole binomial as a numerator. Those are two monomials separated by addition or subtraction. So we need to use the quantity to make it clear that it's everything in the numerator we just listed divided by 2h minus 1. Okay, if you have any questions, please let me know. Let me make this guy bigger. So thank you guys very much for signing in. I'm going to be here every day at this time period. So the Algebra 1 class will run from 6 to 6:45, Mondays, Wednesdays, and Fridays. You can always get the link on my Facebook page. Please like, favorite, and subscribe to my channel. I'm trying to get the permanent YouTube link so then it's not so difficult to try and find my streams. But this is going to be a free service offered to everyone year-round. Again, my name is Mr. Matt. This is Dr. Tot. And thank you guys very much for signing in. And I'll talk to you all on Wednesday.